Welcome. My name is Tomasz Kosek, and I would like to share some techniques we used for zombie crowds in Dying Light 2. Dying Light 2 is a first-person open-world survival action game. It's about parkour, player choices, and exploration. On day one, it was released on Xbox One, Xbox Series X, PlayStation 4, PlayStation 5, and PC. Let's have a look. Right, so a little bit about my background. During the development of Dying Light 2, I've been working as a senior game programmer. My main responsibility was implementation of systems for efficient AI spawning and also implementation of loading algorithm for AI agents. Normally, we would not use a term AI agent in favor of just saying AI. So we have a great team of talented experts back in TECHLAND. So big shout outs to them. And the techniques, all the stuff presented here is a product of a teamwork. So in the world of Dying Light 2, the lucky ones live in shelters and under constant UV lights that would prevent them from turning into zombies, or as we like to call them, infected. So people that were not lucky enough to escape the toll of the virus. So the plan for today's talk is pretty straightforward. Firstly, I will present the design for the population of infected in Dying Light 2. Then I will talk a bit about spawning of infecteds on the streets and inside the buildings, then shed some light on co-op and AI loading algorithm, and say a few words about collaborations between the engineers and level designers and the pipeline for that collaboration in order to challenge the technical constraints during the modeling phase of the population in Dying Light 2. So the action of Dying Light 2 takes place in Velador. Once prosperous city now struggles with the fallout after the virus hit. The design for the population of infected in Dying Light 2 was pretty straightforward. As much infected as possible on the streets during the night, and as much infected inside the buildings as possible during the day. So the sky is the limit. This is what we tend to say when we start a new AAA project. But is the sky really the limit? Because we soon realized, right? From the technical point of view, we soon realized that the real limit for us was the old generation hardware. And as the Dying Light 2 can be enjoyed in 4-player co-op, the real technical limit for us was 4 old generation consoles connected to one game session. So as you can see, from the technical point of view, there was not much of a sky left for us, and the sky is the limit motto. So we found ourselves between a rock and a hard place. In order to fulfill the dense infected population requirements, set for us by the design, we would have to spawn a lot of AI instances in the game world, and we just could not afford to do so. So on old generation hardware. So this sets the background for the techniques presented here. So let's now have a look on the population of infected on the streets in Dying Light 2. So this is obviously a night experience. The player feels that going on a street level would result immediately in engagement in combat with the infected. So there's also infected in the moonlight. And a bit more vertical part of the Velador. So just kindly follow the road. You can see the infected there. They are maybe small from this perspective, but what we wanted to do is make player to feel the floor is lava effect very intensively, so that the player would choose to parkour the roofs instead of running the streets. Right. So now let's see how we approach the spawning of those infected from the technical point of view. So in Dying Light 2, the architecture of AI would split the AI into 4 types. It would be full AI, medium AI, low AI, and crowd AI. And the replacement of one with the other would take place based mainly on the distance from the player. And this architecture did very well for Dying Light 2. But our technical directors saw it risky for Dying Light 2, as it could not be aligned with the dynamics of player actions in Dying Light 2. So our technical directors just came up with a different approach. So instead of having this gradual division of the AI, we would have one AI with its inner systems, and those inner systems would be progressively loaded by a loading system. The loading system would analyze the game context, would check what the player is currently doing, and would apply the load independently to each of AI inner systems. And I will return to it later and talk about it later in detail. So we also thought that it would be a good idea to bake the spawn points for the infected into the level data, not to calculate them during the runtime. So in game we would only query the baked data. So with the architecture and spawn points ready, we would approach the first implementation of spawning of the infected. So it was pretty straightforward. The orange circle would be a field of spawn, the green dots infected, and the blue lines the player's field of view. So it was pretty straightforward. We would just query the spawn points around the player and just spawn the infected there. But in very dense spots, we were only able to spawn as far as 25 meters from the player. It was totally unacceptable. The infected would pop in front of player eye when player would run forward. So why we just couldn't spawn more AIs, over this 25 meters away from the player? We did a lot of measurements, right? And we came up with the fixed maximum number of AI instances that can live in a game world in order not to compromise the 30 frames per second on all generation hardware. And this limit was 80 AIs. So we just were out of budget. But we thought that maybe we can optimize the spawn field. And this actually made the worst case a bit better, because now we could spawn the AIs 40 meters in front of the player for the most dense spots. So the popping of the AIs would not be so visible, while running the crowded street. So the distance behind the player would have like 20 meters. And this actually worked pretty fine for us. but it posed a new problem. So when player would run forward, then as new points would get in range, we would have to spawn few AIs. But if player would look around or perform fast turns, then we would have to spawn a whole bunch of AIs instantly in order if no popping visual artifacts should be visible during those turnarounds. And we were only able to, we could only afford to spawn as much as one AI per frame. So we would reconsider our architecture and we would add a AI cache to the equation. The AI cache would be fueled with the spawned AIs that could be reused again in a game world, and that would boost our performance, our rate of spawning AIs per frame. So we would end up with something like this. So the optimized field of spawn would be supported by cache, for fast turnarounds of the player, and the AI cache would be used not only for the turnarounds or fast camera movements, but also would be default would support the spawning of the AIs by default. And yeah, this actually worked pretty well for the more flattened areas of the Villador, but the distance that we achieved, so we could spawn up to 60 meters in front of the player, 40 meters for the worst cases, but it was not enough for the more vertical parts of the Villador. So we would reconsider our architecture once again, and we would introduce a crowd AI. Crowd AI would have almost no logic at all, would have simple visualization, and would have simple heat reaction. Right. So we would end up with something like this. So the orange optimized field of spawn would be now supported by the blue field for the crowd AIs. We could spawn those crowd AIs as far as 210 meters from the player. And yeah, so I guess we eventually would end up with two types of AIs. We were able to spawn 80 AIs and 1,200 crowd AIs, so a pretty good result. The new problem that posed this solution would be that at some point the crowd AI should transition into the AI, right? Back and forth. So in game, this transition is barely visible as it takes place on significant distances, but I prepared a bit of a close-up on a test map, so let's have a look. So it's an infected high poly, it turns into low poly, right? So pretty straightforward. Yeah, and what is great about this is that, I mean, obviously this kind of a low poly can only be used on significant distances due to its quality. But what is really cool about it is that it's purely animated on the GPU. It's not skinned mesh, so it's animated via the vertices displacement purely on GPU. And it also supports some basic walking animation. Right. So the final picture, for the optimized field of spawn would look like this. So pay attention at the top right corner. You can see the AI radar there. The green dots would represent the AI. The light dots would represent the crowd AI. So let's have a look. The player would look around, and you can see how the field of spawn works in action. So it works pretty fine, for slow moves and a bit of fast turnarounds. So the AIs now during those turns are spawned instantly, right? Right. So that's about it if it comes to the infected on the streets. Yep, so now let's have a look on the indoor population and how we approach the spawning of those infected inside the buildings. So let's have a look on this sample location. It is a loot shop, so the player would approach this location during the day usually, because during the night, sorry, because during the day there is a lot of infected inside. So there are some sluggish ones, but also some violent ones here. I guess if the player build would be focused on the combat, then I guess this location could be also approached during the day. And now let's have a look on the same location, but with some technical insight. So, and kindly pay attention to the popping labels that would indicate the spawn of the AIs. So what you can see here is a simple trigger volume, right, which triggers the spawn of AIs inside the building once entered, right? So pretty straightforward. So now let's have a look on some other location. This is a multi-story building. The player would approach, would enter this location by the doors on the roof. So each floor is filled with infected. This location would be approached also usually during the night, because during the day there is a lot of violent infected inside. So the idea of this location is to just sneak your way or fight your way through all the floors, starting from the very top, going to the very bottom, where the loot is located. Right, now let's have a look on the same location, but with some technical insight. And once again, kindly pay attention to popping labels, right? So the AIs on the floor are spawned within the very close proximity of the player to that floor. So once again, a very simple trigger rule that would take into consideration the floor height. So if such location was about to be modeled by the level designer in the editor, all those triggers would have to be set up manually. Villador is a big city, so a lot of manual setup from the level design side, as each interior location with the AIs would have to have all the triggers set up manually. So, but we did not leave the level designers alone. We implemented a validator that would check if the spawner has a validator set up. This validator would have no knowledge what is the purpose of the location, but this validator could make some assumptions and, for instance, shout out some hints for the user. For instance, that the trigger volume extends out of the building walls. For some locations it was fine, for others it was not. We also implemented automated AI density tests that would traverse the interior locations, opened, closed, traversable interior locations, but also roads, and also each story of the multi-story building. That way the level designers would know if some location does not have too much AI instances spawned, which could pose a performance threat. So because all those triggers had to be set manually, the level designers and level artists would have to be aware about the technical aspects of the spawning. So instead of taking the spawning of the infected for granted, for instance, by some system that would handle all the work, the level designers, level artists would have to prepare the locations from the design side too. So let's take a look on this example. This is a sample of an airlock. So this gives time to spawn the AIs inside the location and also gives time to despawn the AIs outside the location. Right. So the simple trigger rules were very easy to implement and easy to maintain. And it's important. But what is even more important is the beneficial influence of that simplicity on the co-op performance. And here is why. So co-op in Dying Light 2 is implemented based on the peer-to-peer architecture. So up to 4 players can connect and enjoy the game together. Peer-to-peer architecture means that there is no server, so peers to constantly send that data to one another to stay synchronized. So now let's consider this example. So 4 players are fighting the infected crowd on a street. And if those players are within a proximity, they will see the same set of infected. So in order to have the same picture on each peer's screen for those common infected, the peers would have to send a lot of, the network layer would have to synchronize the activity and position of those common infected, and that's a lot of data to send over the network. And that introduces an overhead. But if data is constant, then it must not be sent. For instance, a simple trigger rule. So this trigger volume will never change. It's constant. So the player inside the building, you can see the symbol B in the middle of the screen, perfectly knows if AI data should be sent to player outside the building or not. The player outside the building will not receive the AI data because the player is not inside the trigger volume. And we know all this only by replicating the positions of the peers, between the peers, right? No any additional data. So if there are like 4 players in session, then the player inside the building would have to perform a test for each of other players, whether to send the AI data to them or not. So those are 3 additional calculations per AI. And this is really important that the trigger rules should be as simple as possible to introduce as less overhead in co-op as possible. Right, so this would conclude the population of infected in the interiors. So we were able to spawn up to 80 AIs and 1,200 crowd AIs, but we were not capable. We could not afford to simulate them with the full throttle. So right after the AI instance would be created in the game world, the loading system would connect to it. So to understand how the loading system works in Dying Light 2, let's have a look on those 4 main AI agent subsystems. So it would be model, animation, physics, and decision-making algorithm. So the loading system would analyze the game context and would analyze what the player is currently doing, and based on that, it would apply LOD to each of AI agent inner system via the corresponding API and corresponding condition set. So this is why we say that it's hard to find 2 AIs with the same level of detail in Dying Light 2, as all the systems are loaded independently from the other subsystems, and they are loaded progressively. So here you can see the loading system in action. You can see the green dot next to the infected, which has the LOD of decision-making algorithm bumped up by the loading system. So you can see how this bubble of higher load just follows the player. So those infected should react instantly on player actions. Right. Because the loading algorithm needs to perform a lot of checks, such as whether the player is inside a bandit camp, or whether the player is running the roofs or is running the streets, or is inside a dark zone. It makes it very game specific. So our engine's AI system allows to exchange the loading system so that it can be tailored for the specific game. And what is also important, all the game-specific rules are centralized in this loading system. So those are easy to find and easy to maintain. So here's an example of a bandit camp. You can see that the loading algorithm bumped up the LOD of decision-making algorithm for the AIs in the background, and lowered the LOD of decision-making algorithm for AIs in the middle ground. So this is because the player might want to use binoculars to observe this bandit camp, and would maybe want to plan the attack on this bandit camp from the distance. So this is also an example how the game-specific rule can be superior to a distance rule. So despite the AIs in the middle ground are closer, they have lower LOD of decision-making algorithm. So if we were about to put a number of how the AI loading system would score the AIs, the marked AIs in the distance, it would be having the 0 be the highest lot and 5 be the lowest lot. It would be 5 for the model and physics, because those AIs are very far away. 3 for the animation, because the system needs to support locomotion of those marked patrolling bandits, even the distant ones. And 4 for the decision-making algorithm, because those bandits, every once in a while, needs to select a new point to patrol. So in order to fit the 30 frames per second, each game system would have a tight time budget it could take during the frame update. AI system was not an exception, so loading system was as part of AI system would be impacted of those budgeting as well. So the loading system would have to introduce the limits of its own. So the loading system would, for instance, allow to update as much as 18 behavior trees at the same time, would allow to have up to 10 active ragdolls at the same time, would allow to update senses of up to 18 AIs at the same time. So those numbers seem not significant if you are talking about a crowd of infected. But let me give you this example. If player would stay long enough on the city streets during the night, they would provoke a chase. So additional infected would be spawned and would chase the player to pressure the player, right? So let's say this chase feature would be a game context. Let's say that the AIs in the bandit camp would be another game context, and let's say the infected on the streets would be yet another game context. So those three contexts require calculation from the limited processing power. So it was very important for the level designers not to create the locations in Dying Light 2 that would have all those contexts active at the same time. So no bandit camp in the middle of a crowded street with active chase at the same time. Yeah, but in Dying Light 2, actually all such contexts were set up perfectly so that they would fit very well in the loading limits. So if we would go back to this bandit camp example, you can see that it's located on a sort of an urban island. It's distance from the main road. And there is not a lot of infected around it, right? Right. That would be it. So the bigger the project, the more people work on the project, the easier it is to appreciate the processes. The development of games seems to be the art of getting along. So as engineers, we would put a lot of effort to optimize the AI systems as much as possible to fulfill the design requirements for the population of infected in Dying Light 2. But we would also collaborate with level designers and would be very frank about what kind of features we will not deliver due to the technical constraints. So we were, I guess, introducing this practical element to this sky is the limit motto. So during the development of Dying Light 2, engineers and level designers would agree on some processes, and here are some key points of them. So what is great about this collaboration between the engineers and level designers is that it started way before the game release. So anyone who was very skeptical about the technical constraints could have time to really get along with those technical constraints. We would analyze the locations together, in order to identify what kind of features are required from the AI system side, but also we would communicate what kind of features would not be delivered due to the constraints yet again, right? So we would perform a weekly performance, we would provide weekly performance reports to the level designers so that any performance issues could be addressed systematically. We would do also a lot of knowledge sharing and training for our debug tools. And it was pretty important because those debug tools would allow the level designers to solve the bugs without engaging us, or at least perform a pre-check of a bug. We would also obviously get a lot of design documents from the design side, so that again we were able to identify what kind of features are required from the AI systems, but also identify potential performance risks. I'm not saying all those processes work well every time, but for sure they would contribute into achieving a 30 frames per second on all generation hardware for Dying Light 2. So this would conclude the presentation. As for the company itself, we are hiring, so feel free to find our booth. You will get details about open positions, or just visit our website. As for me, I will do my best to answer your questions, if there are any, of course. And thank you.
Thank you, Tomek. And if you have any questions, please feel free to ask them. Just stand up and come to the microphone on the right here in the stage.
Hi, thanks for the lecture. I'm wondering, because in Dying Light, besides this whole crowd system, you also have some, let's say, special AI, like you have some quest for killing some zombie, etc. Was it also part of this whole system, or it was tracked by some another microsystem? Or?
So the question is, were the NPC AIs also part of this crowd system?
Not exactly. I mean, there was, for example, this mini quest that there was places that you can kill some zombie that was running. I don't remember what was the name of this kind of zombie. Mm-hmm. So it was also, and it has marker on it, yeah. So you know where to go to find him. Mm-hmm. And what was those AI also part of this system, or it was something, some external system, let's say?
Yep. So those AI would be considered as special and were not a part of this system, you know, because shoveling with such important AIs, you know, in this manner could pose some artifacts for the player, you know. So it would be once despawned. Let's say a player would not look at this AI, so this means that this AI could be despawned, and if this AI would move from the start point, when the player would look at this AI once again, it would be at its start point. So this could pose some disorientation for the player, right? So we would only apply this crowd system for the masses, so that this illusion would not be so easily recognizable by the player, you know, within these masses, right?
Okay, thanks.
Thank you.
Hi, thanks for the presentation. So on one of the last slides, you've mentioned that weekly you've sat down with the level designers and you are checking those performance reports. So the question is, did you have any sort of pipeline automated process to check the game performance?
Yes, we would have an automated tool that would traverse the game, and it would check the number of AI instances in the world, but would also check the general performance of the game with all the markers. So if you are familiar with the, for instance, Razor tool, right, the Sony's Razor tool, then this tool, this automated tool would provide some kind of a similar to this Razor's flame charts, right? So that those could be analyzed.
Okay, thanks.
Thank you. Okay, so I guess we can end up on this. So thank you.